Hi, some of us already turned in the homework assignments. I really appreciate that. Today we're going to continue on chapter 13 and chapter 14. We are talking about bearings. And the two big categories of bearings. One is a sliding bearing, and another one we call the rolling element bearing. In those two big categories, we have also two big category, and one is we call it just a normal actual bearing, and another one is thrust bearing. So like the sliding bearing, we categorize into two big types, and one is just the normal actual bearing, and we sometimes call it journal bearing or sleeve bearing. And another type is what we call thrust bearing. Now, journal bearing or sleeve bearing is actually just a hole, and then you have a shaft goes through, and then the shaft, let's say that's a hole here, and then you have a shaft goes through, and then the shaft rotating inside the hole, and this is a sliding bearing or journal bearing. And the reason that we call the sleeve bearing is sometimes we have a case or a sleeve in the support, so to prevent wear. So we call it sleeve bearing. Now, this bearing is actually pretty simple, right? And you can have like your lawnmower, your lawnmower, the wheel goes through that, just a bolt goes through a piece of the body, and that has a hole, and that's a bearing. So bearing is almost like everywhere with a rotating shaft, then you will have a bearing. So the simplest one is just what we call it, the sliding bearing, right? The simplest one is the sliding bearing. And now the thrust bearing is somehow like this, like two discs. If you have two discs, that's a thrust bearing. Now that's rotating here, that's rotating here. If you have two discs, and this disc rotating on this one, this is a thrust sliding bearing here. And we'll talk about a rolling element bearing later on. This one here, the sliding bearing, certainly for our lawnmower application, we don't have to do anything, right? But most of high-speed application, like airplane, we need to have a lubrication. And the lubrication, actually there are three types of lubrication. You have gas, which is really rare. That's really rare. Okay, you have gas, you have liquid. That's most common, liquid. Then you have solid. Oh, you would think, wow, solid. How come we use solid as a lubrication? But actually, some solids like graphite, they are very good lubricant. Interesting, right? Liquid is like grease, oil, something like that. Okay, now because of the lubrication, the best one is that you have lubricant cover in between the shaft and the hole, right, or the sleeve. If you have lubrication in between that's the best scenario. So there is a phenomenon, it's called starting. And this one here is very hard when the bearing is at rest. When it's at rest, this shaft is going to squeeze out those lubrication to the sides. So the starting is really important. It takes more torque. And once it's started, then we have something, this shaft acts like a pump. We have something called hydrodynamic lubrication. Hydrodynamic lubrication. And hydrodynamic lubrication is going to make a perfect situation that you have this gap between the shaft and the sleeve covered with lubrication here. Now this situation will not be achieved when this one is at rest. That's the reason that a lot of airplanes, you see a lot of airplanes, when they park in the airport, waiting for next group of passengers getting on board, they don't shut off the engine. They don't shut off the engine, and because they don't want to have this shaft not lubricated. So that's hydrodynamic lubrication. Okay, now let's take a look for rolling element bearing. And rolling element bearings, there are the most common one is the ball bearing we have. We all know that, ball bearings, and that's the most common one. Besides that one, we also have some other type. We have roller bearing, ball bearing, that's the most common. And also we have roller bearing, and most common one is what we call cylindrical, just like a cylinder, this roller here, cylindrical. And also we have spherical, and that's one like this, like a drum. It's like a drum. Okay, spherical. It's not a ball, but it's like a drum. And then we have tapered. So this, later on we'll talk about that. This is for angular bearing. Okay, for angular bearing, this one here. And then we have something we call the needle bearing. This is also a needle bearing. It's also, the rolling element is a needle. It's also like a cylindrical, but it's just this one is really, really tiny here. So we have those type. And we have actual bearing, those two types, and the thrust bearing. We have those two types. There's another type is called angular bearing. So actually we have three types in rolling element bearings here, but the main type is actual and thrust. No, not actual, radial bearing and the thrust bearing. So those are the main type here. And those are the main type. Now, for any radial ball bearing, for example, any radial ball bearing, that's the most common radial ball bearing. The design is that mainly you have balls here, you're taking radial load, but any radial ball bearing is supposed to be able to take 20% of the radial load as actual load. Radial load as actual load. So it's not like you cannot take any actual load at all. You can still take 20% of the radial load as actual load. Okay. Now next, we're going to take a look at the comparison. Okay, we're going to compare, like, let's compare the sliding bearing and rolling element bearing, like the ball bearing. We compare those two to see what kind of situation we need to use which. So we compare those two bearings, and certainly friction here, and friction is the sliding bearing is high at low speed and low at high speed. And this one, rolling element bearing, is low at low to high speed, low to medium speed, Now what is low to medium speed? Anything like below 300 RPM we call it low. So this low here, low is below 300 RPM. And the medium is low. Normally we talk about 300 RPM to let's say 5,000 RPM. That's medium. And high is normally more than 5,000 RPM. And that's what we call high. Okay. Now, that's the reason that if you have a tachometer, tachometer or tachometer, that gives you the RPM of your vehicle, and normally in that range, about 5,000, you'll see a red mark over there. It's in the red range, right? And because it's high speed. Now, application. The application here, because of the friction, and the application is this one is low speed, like your lawnmower, and high speed, like airplane. Airplane sometimes can go as high as 100,000 RPM. And this one is low to medium. Okay, low to medium here. That's application. Where you want to use a rolling element bearing, where you want to use a sliding bearing. And that's the situation, depending on the RPM, the speed. And the cost. Normally this one is higher. This one is lower. Okay, this one is lower. And noise. Normally this one is higher. The ball bearing is higher noise. This one is lower. Okay. And now another thing is that when you drive a car, you drive through a pothole. Right now, the road is full of potholes, and that's what we call impact. You drive through a pothole. Pothole is an impact load, and to handle the impact load, this one is better. This one is worse. The ball bearing. That's how you get your bearing, your vehicle bearing go bad. Is you drive through those potholes. What else? And those are the are the things that take into consideration when you select the bearing over there. Also size, space, size. This one here, it takes more actual space. This one takes more radial space. So when you design a machine, depending on the space available, if you have a very tight radial space, you probably want to consider a sliding bearing over there, sliding bearing. Okay.